Let's find the derivative of the given functions. So first function here, y equals 2x cubed plus 4. We know that dy over dx is equal to 3 times 2 is 6, and then x cubed becomes x squared, plus the derivative of 4 is 0, which we don't have to write down. Next function, dy over dx is equal to 3 times 2 is 6, x cubed becomes x squared, minus the derivative of 6 is 0. And here, dy over dx is also equal to 6x squared. Derivative of 0 is 0. Dy over dx is equal to 3 times 2 is 6. X cubed becomes x squared, plus the derivative of k, there's no x, therefore it's 0. It's a constant. K is a constant. So we don't have to write that down here. So, all right, what do we notice here? First, we see that the 4 functions that we derived are actually different functions. They will give us different graphs. But we notice that their derivatives are all the same. So this tells us that the derivative 6x squared is the derivative of infinitely many functions. So these are not the only functions whose derivative is 6x squared. We can think of 2x cubed plus 1 having derivative 6x squared. We can have y is equal to 2x cubed plus 1/2. That will also give us a derivative 6x squared. So again, we say that there are infinitely many functions whose derivative is 6x squared. Now, these equations that we got, the derivative, we can call them differential equations. Okay, so let me just take this here. All right, so these equations are differential equations. So let me just illustrate which one it is. So that's a differential equation. Dy over dx is a differential equation. This is a differential equation. Well, they're all the same. Shall we? Okay. Now, what is a differential equation? Well, first of all, what is a differential? Well, whenever we have dy, we call it differential dy. So let me just bring it up here. So dy means differential dy, and it means infinitely small change in y. And whenever we see dx, we can think of that as differential dx, and the meaning of that is an infinitely small change in x. So we can use this idea when we're comparing the changes that occur in one variable and how does it affect the other variable. So here we have x and y related to each other by this equation. So we know that x affects y. So this helps us determine when x changes, how does that affect y. All right, so now since we have here equations, we are going to be solving differential equations. So that's a new thing for the second semester, solving differential equations. So how do we solve differential equations? So let me bring our differential equation over here. So we have dy over dx is equal to 6x squared. Now, since dy, differential dy, are infinitely small changes in the variable, that means these are numbers. And so we can think of this as a fraction. Dy over dx is a fraction. And so we can rewrite this function as dy equals 6x squared dx. So it's like we multiplied both sides of the equation by dx. And so we come up with this equation now. dy is equal to 6x squared dx. So this is another form of a differential equation. This is the same as this one. It's another way of writing this equation. All right, so now, how do we solve differential equations? To solve for the differential equation, we are going to look for the function whose derivative is 6x squared. So again, to solve the differential equation, we need to look for the equation whose derivative is 6x squared. And so we know that from here that there are at least, we can identify at least 4 of those equations. And we know that that's not all. We could find many more equations whose derivative is 6x squared. So that process of finding the function whose derivative is 6x squared is called antidifferentiation. We are going to find the antiderivative of dy. The antiderivative of dy is also called indefinite integral. Okay, so in symbols, this is this is the symbol for antiderivative, a long S. All right, so and if we are going to find the antiderivative of the left side, we have to also find the antiderivative of the right side of the equation. So whatever you do to the left, you do to the right. So we can think of this as an operation, which is undoing the derivative. So we undo the derivative. So the antiderivative of the derivative, they will cancel each other. So we'll have here y. Again, the antiderivative of the derivative of y is equal to y. So now we want to find the antiderivative of 6x squared dx. So what function gives us the derivative 6x squared? So we have to undo or to reverse the process of finding the derivative. So how do we do that? Now we have here already 6x squared, so we're going to have here 6 times. Now, remember that when we derive, we reduce the exponent by 1. So if this is x squared here, originally it was x squared plus 1. So let's write that down, x and then to the 2 plus 1. Now, so originally the exponent was 3. And then in order to derive, we take that 3 and multiply by the coefficient of x. And then we reduce the exponent by 1. So we have to undo that multiplying. So again, when we derived, we took the 3 and multiplied by the coefficient of x. So we undo that multiplying. So we are going to divide. The opposite of multiplying is divide. So we will divide by 2 plus 1, or 3. Plus, now remember that we can put here a 0. And the derivative, 0 is a derivative of any constant. So we can think of having a constant here, and we can represent that constant as c. Okay, so to simplify, we'll have here y is equal to 6 times x cubed all over 3 plus c. And so we'll have here y is equal to 6 divided by 3 is 2, x cubed plus c. This is the antiderivative of dy. Notice that this function looks like these guys, only we cannot specify c. We don't know exactly what c is. It could be any number, any constant. All right, so this is called the solution to the equation. This is the answer we're looking for. So we call this solution to the differential equation. And because it's not a specific equation, then we call this the general solution. To the differential equation. Okay. And this solution is also called, you can also call it the indefinite integral of the differential equation, or we can call it antiderivative. Okay. Now, the variable c is called the constant of differentiation. The constant constant of integration, because we're integrating. All right. Okay, so in the first semester, we looked for the derivatives. Now, in the second semester, we are going to do the opposite of finding the derivative, which is solving differential equations or finding the integral or antiderivative of the functions.